Hi all. Today we are going to discuss question number 22 of Chemistry GATE 2020. Let us go through the question. When 3 moles of helium is mixed with 1 mole of neon at constant temperature and pressure, 25 degrees Celsius, 1 atm, the entropy of mixing in joule per Kelvin rounded off to 2 decimal places is given R is equal to 8.314 joule per Kelvin per mole. So, from the question, we can understand that we are asked to find out the entropy of mixing. So, to answer this question, the main concept which we have to have a basic understanding is the thermodynamics of mixing. Let us have a brief understanding about what is Gibbs energy of mixing and entropy of mixing. Say for example, two perfect gases are taken in two containers, Na and Nb, both at temperature T and at pressure P. To calculate the delta G of mixing, we have to calculate it by forming the differences between the Gibbs energy before mixing and Gibbs energy after mixing. By doing so, we get an equation for delta G mixing, which is equal to nRT into XA ln XA plus XB ln XB, where N is the total amount of A and B. XA is equal to mole fraction of A and XB is the mole fraction of B. So with this, we get to know the equation of delta G of mixing. We already know that dou G by dou T at constant pressure and number of moles is equal to minus S. With this understanding, we can calculate the entropy of mixing, where delta S mixing is equal to dou delta G mixing by dou T at constant pressure and number of moles is equal to minus nR XA ln XA plus XB ln XB. These are the given things. The number of moles of helium is equal to 3, number of moles of neon is equal to 1, and total number of moles then becomes equal to 4. To calculate the mole fraction of helium, we know that it is 3 by 4, and the mole fraction of neon, it is equal to 1 by 4. And in this question, it's given that temperature is equal to 298 Kelvin and R is already given in the question, which is equal to 8.314 joule per Kelvin per mole. So, we just have to substitute these values to the equation of delta S mixing, which is equal to minus nR XA ln XA plus XB ln XB. Now we are substituting these values here. So where N is equal to 4, R value is equal to 8.314, mole fraction of helium is equal to 3 by 4 into ln 3 by 4 plus 1 by 4 into ln 1 by 4. Now we are just solving this equation which becomes equal to minus 4 into 8.314 into this complete portion becomes equal to minus 0.2157 and this portion becomes equal to minus 0.3465. Now summing these two negatives in the bracket, it becomes equal to 0.56227. So now we just have to multiply these values, and since we have already one negative in this equation, the final answer becomes positive, which becomes equal to 18.69 joule per Kelvin. So the solution given by GATE, the answer can come in between the range of 18.60 to 18.80, and we have got a value of 18.69 joule per Kelvin. For more details on this topic, please go and watch NPTEL lectures on the topic of thermodynamics of mixing by Professor Arjit Kumar Dey at IISER Mohali. The YouTube link is also attached here. Thank you.